Okay, so now we're going to do 6.5, which is the mean value theorem. We did the mean value theorem for derivatives earlier on, but this one is for integrals. And what this says, if you should find the area under a curve, or the definite integral between a and b of y equals f of x, you could do an underestimate, or you could do an overestimate, right? An area of a rectangle more than the actual area or smaller than. The mean value theorem says this: if you're trying to find the area under the curve, somewhere between the underestimate or the overestimate, there's a value c, where if you take f of c, if you take the height at c, or f of c, you times it by b minus a. This is b, this is a. So if you take f of c times b minus a, that rectangle, b minus a times f of c, the area of that rectangle is the area under the curve. So the integral from a to b f of x dx equals f of c times b minus a. Okay? So, but you're gonna have to find this value c. So here's the statement of the theorem. If f is continuous over a closed interval ab, then there is at least one c in ab, could be the endpoint as well, such that the integral from a to b f of x dx is f of c times b minus a. So here is an example. Find c that satisfies the mean value theorem for integrals if f of x equals square root of x over 4/9. So f of c times b minus a is the integral from a to b f of x dx. So c is what we're trying to find, f of c. B minus a is 5, equals from 4 to 9 x to the 1/2 dx. So 5 f of c equals x to the 3/2 times 2/3, 4 to 9. 5 square root of c, f of c is square root of d, equals 2/3. 9 to the 3/2 minus 4 to the 3/2. So 5 root c is 2/3, that's 3 cubed is 27, and 2 cubed is 8. 27 minus 8 is 20, so 38 divided by 5, 4 times by 1/5. Root c is 38 over 15, so c equals 38 over 15 squared. In your calculator, it's roughly 6.4, which belongs to the interval 4/9. So basically, just to explain what we just said, if you're trying to find the area under the curve square root of x over 4 and 9, square root of 4 is 2, square root of 9 is 3. If you're trying to find this area, all you have to do is find 6.4, roughly 6.4, do f of 6.4, times it by b minus a, times it by 5. So 5 times f of 6.4 is going to give you that area. Alright, so that f of c that you get, the mean value theorem, is called the average of function f over AB. It makes why this is called the average, because it gives you the exact area under the curve by using that as the width, and then the length, and then b minus a is the width. So let's write this down. Average value of a function over a closed interval AB. So if f is integrable over b, then the average, so when they ask for the average, that means they want f of c of f over AB is exactly f of c that we know, which is 1 over b minus a integral from a to b f of x dx. Remember, we had f of c times b minus a, so if we divide by b minus a, we get the formula. So if I say on this, find the average of f of x equals 1 over 2x over the interval between 1 and 4, then you would say f of c is 1 over b minus a integral from a to b f of x dx. So 1 over 3, 4 minus 1 is 3, from 4, 1 over 2x dx. So it's 1/3 times 1/2 is 1 over 6. I pulled the 1/2 out. Integral of 1 over x is ln of x between 1 and 4. So it's 1 over 6 ln of 4 minus ln of 1, which is roughly 0.23. That's the average of f. So if you take that value and times it by 3, b minus a, that's going to give you the area under the curve between 1 and 4. Number 6, page 475. Number 6, page 475. So we have f of x equals x squared over x squared plus 3 squared, and the interval is negative 1, 1. And it says find the average of the function over the given interval. So average f of c is 1 over b minus a to b f of x dx. 1 over 1 minus negative 1 is 2. X squared over x squared plus 3 squared dx. So obviously we need sorry, this is x cubed. Copied that wrong. X cubed. So we need u substitution. So let u equal x cubed plus 3. Du by dx is 3x squared. So du is 3x squared dx. So we're going to need a 3 to make all this du. And this would be u squared. So we need 1/3 on the outside. So we would have 1/2 times 1/3 is 1/6 integral of du over square. Remember, I leave the limits out until I bring x back. Integral of u to the negative 2. U to the negative 2 plus 1 is negative 1 divided by negative 1, which is negative 1 over 6u. We bring x back. U is x squared 3. And then we're going to bring the limits back. And we would have, if we plug the 1 in here, negative 1 over 4 times 6 is 24, minus negative, so it's a plus. Plug the negative 1 here, it's 1 over 6 times 4 is, so if you plug the 1, 4 times 6 is 24, plug the negative 1, that's 2 times 6 is 12. So it's 1 over x cubed. So it's 1 over 24. Okay, that's fine. Alright, one more, number 10, page 475. It says find the average value of f, find c in the given interval such that f average equals f of c. Okay, so g of x equals x plus 1 cubed. The interval is 0, 2. So first find average of f of g over 0, 2. So it's g of c, 1 over b minus a, interval a to b, g of x. So we're using g instead of x. So f minus 0, 0 to 2, x plus 1 cubed dx. So it's 1/2 x plus 1 to the 4 over 4 between 0 and 2, so it comes out to 10. That's the average of g over a part C. We want to find find C such that f average equal f of C. So C is how much if g average equal g of C. Okay, so g average equals g of C. We just found g average, which is 10, equals g of C is c plus 1 cubed. This is average of g. Okay, we call it g of C, but average of g. Average. Okay, so c plus 1 cube equals that. So cube root of 10 is c plus 1. So c equals cube root of 10 minus 1. So it's about 115. And see, they want you to do that. So you do the graph. It's in the notes. And that's it for 6.5.